Let us understand today different properties of noiseless channel. So first we will see what is noiseless channel. The channel with the channel matrix having one and only one element in each row as well as in each column is called noiseless channel. So the channel matrix here is example of a 2 by 2 channel matrix. You already know what is a channel matrix. Channel matrix is the matrix of probabilities output given input, that is P probability for P for probability, Y for output symbols, X for input symbols. So probability output given input is the channel matrix. So the inputs are represented by X1, X2 and outputs are Y1, Y2. So here in each column there is one element and in each row there is only one element. So such a matrix is called noiseless matrix. Now this one can be here also. So the condition is that there should be only one element in each row and one element in the each column. And second condition for the channel matrix is the rows elements addition is equal to 1. So here 1 plus 0 is 1 and 0 plus 1 is 1. That we already discussed what are the properties of the channel matrix. Now in this video we are going to see if such matrix is there, such channel matrix is there, which is called a noiseless channel matrix. So what are its properties, what are its parameters, we can say. So here I have written it as Py1 given x1 is equal to 1, this one, and Py2 given x1 is equal to 0, Py1 given x2 is equal to 0 and Py2 given x2 is equal to 1. So we have seen in one of the video how to obtain different probability matrices when you have this matrix or when you have the channel matrix. So the next is you should be provided with the input probabilities. So let Px1 is equal to A1 and Px2 is equal to A2. So here Px1 is equal to A1 and Px2 is equal to A2. So how to obtain the joint probability matrix Px comma y? You have to multiply this row with Px1 and this row with Px2. That we have already discussed in the video. I think that is how to obtain different probability matrices when the channel matrix is given. So the joint matrix is obtained by multiplying this row with Px1 and this row with Px2. So Px1 is A1 and Px2 is A2. So here it is 1 into A1 and 1 into A2 is A2. Now Hxy, that is entropy Hx comma y, can be obtained. For that you should know, you should see how many probabilities are there in Pxy matrix. So there are 4 probabilities, and to obtain the entropy you already know that you have to represent these probabilities like A1 log 2 of 1 by A1, 0 log 2 of 1 by 0, that you know. So the same is here, A1 log 2 of 1 by A1 and A2 log 2 of 1 by A2, because 0 not needed to represent. So Hxy is equal to A1 log 2 of 1 by A1, A2 log 2 of 1 by A2. Now what is Hx? For finding the entropy Hx you should be provided, or you should know the you should see the what are the probabilities of x. So there are 2 probabilities, Px1 and Px2. So again for Hx you have to write A1 log 2 of 1 by A1 and A2 log 2 of 1 by A2. So this shows that Hx is equal to Hxy for the noiseless channel. That means entropy of input is equal to joint entropy. Now we can obtain the output probabilities Py1 and Py2 from the joint matrix. If you have provided with the joint matrix, you can find the input and output probabilities. Input probabilities can be found by addition of the rows elements. So px1 is a1 plus 0, that is a1. Px2 is 0 plus a2, that is a2. Py1 is a1 plus 0, that is a1. Py2 is 0 plus a2, that is a2. So py1 is a1 and py2 is a2. Now again hy, two probabilities. So a1 log to 1 by a1 plus a2 log to 1 by a2. So we come to the conclusion that hx is equal to hy is equal to hxy, because in symbol y also there are two probabilities, a1 and a2. In x comma y there is also four probabilities, but two are 0. So again a1 a2. In symbol x there are two probabilities, a1 a2. So hx is equal to hy is equal to hxy for the noiseless channel. Now hy given x is equal to hx comma y minus hx. This you know, this formula, because this was also we have discussed it. So hxy is equal to hx minus hx. Hx comma y is hx, so here, so hx minus hx is equal to 0. So hy given x, that means conditional probability hy given x is equal to 0. Now let us see hx given. What is hx given y? So that is equal to hxy minus hy. This formula I think you should have recalled it very much, because we have discussed this formula many times. So hx given y is equal to hxy minus hy. So hxy is equal to hx. So hx minus hx is equal to 0. So conditional probability conditional entropy hx given y is equal to 0. So both these conditional entropies are 0. So what is the mutual information? Ixy is equal to hx minus hx given y. Now hx given y is equal to 0. So Ixy is equal to hx for the noiseless channel. So what is the meaning of hx given y 0? Is that outputs of noiseless channel are sufficient by themselves to specify input to the channel. So average number of minutes necessary to specify inputs when we know the output is 0. So what is entropy? Entropy is the average number of minutes necessary to represent input when we know the output. That is equal to 0. That means output itself is sufficient to represent the input. There is no need to have that means there is no uncertainty in that. If you understood the output, if you see the output, you can guess that what is the input. If you see the output here also, you can guess what is the input. So that the uncertainty hx given y is equal to 0, and mutual information is equal to hx. So that's it for this video. So if you like this video, give a thumbs up and do consider subscribing to the channel. Thank you.